Hi sweeties! For today's video, we're going to talk about measures of central tendency, to talk about the mean, median, and mode. There are two major concepts in describing the assessed performance of the group. First is the measures of central tendency, next is the measures of variability. Measures of central tendency are used to determine the average score of a group of scores, while measures of variation indicate the spread of scores in the group. These two concepts are very important and helpful in understanding the performance of the group. Measure of central tendency is a value that describes to which a set of data will likely fall. The three measures of central tendency of data are the mean, median, and mode. Measure of central tendency provides a very convenient way of describing a set of scores in a single number that describe the performance of the group. It is also defined as a single value that is used to describe the center of the data. It is thought as typical value in a given distribution. As I have said, there are three commonly used measures of central tendency. Those are the mean, median, and mode. In this section, we shall discuss how to compute the value and some of the properties of the mean, median, and mode as applied in a classroom setting. First, let's talk about mean. Mean is the average of a set of data and is denoted by the symbol X and an underline on top. It is the value equal to the sum of all the values in a data, or the summation of X divided by the total elements in a given data, or the N, and is now summarized by the formula given below. So mean is equal to the summation of X all over N. For example, we're going to find the mean of all the grades of James in his engineering course if his grades are as follows. In mathematical analysis, he got 90, in world literature 78, discrete math 92, calculus-based physics 89, engineering economy 96. So in those data, we're going to use the solution that we presented a while ago. Next, we're going to compute all the summation of data and we get 445, and we will divide it into 5 because that was the number of our data, and 445 divided by 5, we get 89. So that is our mean for ungroup. Next, we're going to compute the mean for group data. So you must remember that we have different ways in computing the mean for group data and ungroup data. You must remember that we have different ways in computing group data and ungroup data. So now let's talk about the mean for group data. Group data are score distribution that are arranged in a frequency distribution. So when we talk about frequency distribution, it is the arrangement of scores according to category of classes, including the frequency. And when we talk about frequency, it is the number of observations falling in a category. So let's take a look with this formula. Mean is equal to summation of F multiplied by X divided by N, where X is our mean value, the F is our frequency in each class or category, our X is the midpoint of each class or category, and summation of Fx is the summation of the product of frequency and the midpoint of each class or category. Our N would be our number of cases. So let's take a look with this example. Here are the result of scores in mathematics tests during the teacher's board examination are summarized by the table below. So we're going to find the mean of the score of all the examples. So we have here the class interval from 10 to 20, 21 to 31, 32 to 42, 43 to 53, 54 to 64, 65 to 75, 76 to 86, 87 to 97, and 98 to 108. And on the right side would be our class frequency. 5, 10, 11, 7, 23, 56, 6, 8, and 4. So already input here our data. So we're going to calculate now the mean of this data. Now we're going to compute the mean of this data. But first, we're going to get the midpoint or the class mark of each class or category using the formula xm is equal to the lower limit plus the upper limit, and we will divide it into 2. For example, in 10 to 20, we're going to add 10 plus 20 divided by 2, we get 15. 21 plus 31 divided by 2, we get 26. 32 plus 42 divided by 2, we get 37. 43 plus 53 divided by 2, we get 48. 54 plus 64 divided by 2, we get 59. 65 plus 75 divided by 2, we get 70. 76 plus 86 divided by 2, we get 81. 87 plus 97 divided by 2, we get 92. 98 plus 108 divided by 2, we get 103. Now, we're going to multiply the frequency and the corresponding class mark so that we get the FXM. If we're going to multiply the class frequency in the first group, 5 multiplied by 15, we get 75. 10 multiplied by 26, we get 260. 11 multiplied by 37, we get 407. 7 multiplied by 48, we get 336. 23 multiplied by 59, we get 1,357. 56 multiplied by 70, we get 3,920. 6 multiplied by 81, we get 486. 8 multiplied by 92, we get 736. And 4 multiplied by 103, we get 412. Now, we're going to compute. We're going to get the summation of Fx. And if we're going to add 75 plus 260 plus 407 plus 336 plus 1,357 plus 3,920 plus 486 plus 736 plus 412, we get 7,989. Now, we're going to solve the mean using the formula that I've presented. So, we have here mean is equal to summation of Fx divided by n. And 7,989 divided by 130, where do we get 130? You're just going to add the data in the class frequency and you get 130. Now, using 7,989 divided by 130, we get 61.45. So the mean of our data is 61.5. It means that the mean scores of examinees is 61.45. Those students who got scores below 61.45 did not perform well in the SAD examination, while those students who got scores above 61.45, they are the examinees performed well in the examination. The mean performance of 130 examinees got 61.45. So those students who got scores below 61.45 did not perform well in the SAD examination, while those examinees who got scores above 61.45, they perform well in the SAD examination. This data, it shows the scores in statistics exam. We're going to find the mean scores of 30 students if 9 class intervals shall be used in grouping the data. I already circled the highest score and the lowest score. So the highest score here is 90 and the lowest score here is 47, so that it is easily to compute the range. So we're going to determine the range. R is equal to 90 minus 47. We get 43. In our step 2, we're going to determine the desired number of class intervals. So the problem requires 9 class intervals. So step number 3, we're going to determine the class size. So our class size is equal to 43, then divided by the class interval, which is 9. And 43 divided by 9, we get 4.78 or 5. Step 4, we're going to construct and fill up the frequency distribution table. Step 5, we're going to make the class intervals. So we start with the lowest score until the highest score is reached. Note, 47 is the lowest value from the data and our class size is equal to 5. Now, our step 6 is we're going to determine the class boundary. So we're going to disregard this step since class boundary is not yet significant in solving for the mean of group data. And our step 7, determine the class frequency or how frequent those numbers appear in that group. Here is our table that we've created using those data. Our class interval here, we have the group 1 from 47 to 51, if we're 52 to 56, 57 to 61, 62 to 66, 67 to 71, 2 to 76, 77 to 81, 82 to 86, 87 to 91. Now, I already included its class frequency. And how do we compute again the class mark? That's right, we're going to add the lower limit plus the upper limit and we will divide it into 2. For example, in the first group, we have here 47 plus 51, and if we're going to divide it into 2, we get 49. 52 plus 56 divided by 2, we get 54. 57 plus 61 divided by 2, we get 59. 62 plus 66 divided by 2, we get 64. 67 plus 71 divided by 2, we get 69. 72 plus 76 divided by 2, we get 74. Until 87 plus 91 divided by 2, we get 80. Fx or multiplying the class frequency and its class mark. So we have here 4 multiplied by 49, we get 196. 3 multiplied by 54, we get 162. Until 4 multiplied by 89, we get 356. And now we're going to sum all the data in the column Fx. And if we're going to add 196 until 356, we get 2031. And our class frequency, if we're going to sum it all, our population here would be 30. And using the formula of mean, we get 2031 divided by 30. Our mean here is 67. Our mean here is 67.7. So it means the mean performance is 67.7. So those students who get scores below 67.7 did not perform well in the SAT examination, while the students who get scores above 67.7 perform well. So the properties of mean says it measures stability. Mean is the most stable among other measures of central tendency because every score contributes to the value of the mean. Next, the sum of each score distance from the mean is 0. Next, it is easily affected by the extreme scores. It may not be an actual score in the distribution, can be applied to interval level of measurement, and lastly, it is very easy to compute. When to use the mean? We use mean when sampling stability is desired. Other measures are to be computed such as standard deviation, coefficient of variation, and skewness. Now, let's talk about median. Another important measure of central tendency is the median. It is usually denoted by this symbol. By definition, median is the value of the middle when all elements in a set of data are arranged in ascending order. If the number of elements in a given set of data is odd, exactly one element in the middle, when the data is arrayed in ascending order. However, if there is even number in a set of data, there will be two elements to be considered in the middle so that the median for a set of data with even number of elements is equal to the average of two middle elements. So in this example, we're going to find the median of the measured height of all the athletes of the YMA University given below. So our data is 181, 211, 195, 189, 200, 206, 195, 188, 189. So our step 1 is we're going to identify the location of the median element using the given formula. So median is equal to n plus 1 divided by 2, where our n is the total number of elements in a set of data. In this problem, our median is equal to 9 plus 1 divided by 2, and we get 5. Therefore, the fifth element is the median element of the given data. Next step is we're going to arrange the data in ascending order. This data, if we're going to arrange it shows 181, 188 until 211. Now, our step number 3, we're going to take the fifth element in the array data as the median as in step number 1. So, our median is equal now to 195 because 195 is our fifth element in the arrayed data. Next example, we're going to find the median of the following row data. So we have here 5, 11, 3, 6, 9, 11, 6, 12, 16, 4, 6, and 10. So our step number 1, we're going to identify the location of the median element using the given formula. So our m is equal to n plus 1 divided by 2. And in this data, we have 12. 12 is the number of our population. N is 12 plus 1 divided by 2, we get 6.5. Therefore, the 6 and 7 elements are the median elements of the given data. As you can see, 12 is even number. Unlike in example number 1, our n there is an odd number. So in this case, we're going to arrange the data in ascending order. So we have here 3, 4, 5, 6 until 12. Next, we take the average of the 6 and 7 elements in the array of data as the median, as in step number 1. So we have here 6 plus 9 divided by 2, we get 7.5. But there is a difference between computing group data and ungrouped data. Now, let's talk about median for group data. Arranging the data in ascending order is easy only for ungrouped data, but this is no longer possible for group data. As I have said, there is a difference between computing the ungrouped data and for the group data. The frequency distribution table is now important in the calculation of median of group data. The median of group data can be calculated using the formula given below. In this formula, XLB is equal to the lower class boundary of the median class, our I is equal to the class size, N would be the total number of frequencies, the less than CFB is the less than cumulative frequency before the median class, and FM is our class frequency of the median class. How to get the median class? The median class is the class interval to which M is included with respect to the less than the cumulative frequency. For group data, M is calculated by dividing the total number of frequencies by N divided by 2. Let's take a look with this table. The table that we that we've computed in mean. In this table, we have the class interval and the class frequency. So in the first group from 10 to 20, we have here 5 frequency until 4. So how do we get the less than cumulative frequency? First, let's start on the top. Then we're going to proceed in successive addition. First, we're just going to start on the top and proceed to successive addition. For example, let's write 5. Next, 5 plus 10, we get 15. Next would be 15 plus 11, we get 26. 26 plus 7, we get 33. 33 plus 23, we get 56. 56 plus 55, we get 111. 111 plus 7, we get 118. 118 plus 8, we get 126. 126 plus 4, we get 130. And the last data here would be our n, which is the total number of our data. Now we're going to compute the median class. Median class is equal to n divided by 2. Since in that table it shows that our n is 130, then we're just going to divide it into 2. So 130 divided by 2, we get 65. Since m is 65, therefore the median class is the class interval from 65 to 75. Since it includes elements from 57 to 111 when arranged in ascending order, unlike class interval 54 to 64, which includes only elements from 34 to 56. Now that we know our median class, we can now get the values needed for the formula of median for group data. So, para hindi kayo maguluhan dahil 65 ang nakuha natin sa median class, hindi porket na 65 ang nandyan, pupunta na tayo agad doon sa class interval na from 65 to 75. No, it's not. Punta tayo sa column ng cumulative frequency. I-check natin kung saan magpo-fall ang 65. Is it sa group ba ng 54 to 64? So, sa group ng 54 to 64, andoon ang 56. So, yung 56 na less than cumulative frequency, hindi siya pwede sa ating median class. So, yung 65 natin, magpo-fall siya sa group ng from 65 to 75 dahil naka-include dyan yung 65 sa 111. Kaya, kinuha natin yung group na 65 to 75. So, in this table, we're going to get the lower class boundary of the median class. So, let's recall how do we get the lower class boundary. So, in lower class boundary, it is equal to the lower class limit. So, we're just going to subtract 0.5. In upper class boundary, it is equal to upper class limit, and we're just going to add 0.5. So our lower class boundary of the median class is 65 minus 0.5, we get 64.5. So where do I get the 65? From the group of 65 to 75. Next, let's proceed to the class size or I. So our class size is equal to the upper class limit minus the lower class limit plus 1. So class size is equal to 75 minus 65 plus 1. It is equal now to 11. Next, let's get the less than cumulative frequency before the median class or the less than CFP. So by looking at the frequency distribution table, our less than cumulative frequency below the median class is 56. Next, let's compute the FM or the median class frequency. So by looking at the frequency distribution table, our FM or our median class frequency is 55. If we're going to use the formula that I presented a while ago, median class is equal to the lower boundary plus the class size multiplied by n divided by 2 minus the less than cumulative frequency all over FB is equal now to our lower boundary a while ago is 64.5 plus our class size is equal to 11, multiply it by 130 divided by 2 minus 56 all over 55, and the total is 66.3. So if we're going to interpret this, the median value is 66.3, which means that 50% scores are less than 66.3. Let's take note the properties of first, it may not be an actual observation in the dataset. Next, it can be applied in ordinary level. Next, it is not affected by extreme values because median is a positional measure. When to use the median? If we're going to get the exact midpoint of the score distribution and there are extreme scores in the distribution. Next is mode. Mode is defined as the element in a set of data that has most number of frequencies. In an ungrouped data, mode can be simply identified by inspection. Mode is denoted by this symbol. The mode or the modal score is a scores that occurred most in the distribution. It is classified as unimodal, bimodal, trimodal, and multimodal. So when we talk about unimodal, it is a distribution of scores that consists of only one mode. When we talk about bimodal, it is a distribution of scores that consists of two modes. When we talk about trimodal, it is a distribution of scores that consists of three modes, or multimodal is a distribution of scores that consists of more than two modes. Let's take a look with this example. What is the mode of the measured height of all the athletes using the given data below? So we have 181, 211, 195, 189, 200, 206, 195, 188, and 189. So step 1, we're going to list down all the values and their corresponding frequencies. Step 2, take the value that has the highest frequency. So in this data, the highest frequency is the 195 and 189 because it appears twice in the given data. Now let's talk about properties of mode. First, it can be measured when the data are qualitative as well as quantitative. Next, it may not be unique. Next, it is not affected by extreme scores. And lastly, it may not exist. When to use the mode? When the typical value is desired and when the data set is measured on a nominal scale. Now, you already know how to compute the mean, median, and mode. Again, measure of central tendency provides a very convenient way of describing a set of scores with a single number that describes the performance of the group. And you must not forget that there are three commonly used measures of central tendency. These are the mean, median, and mode. That's all for today, sweetie. See you on the next video.